Hi, welcome to my channel Yanam Takshasila. In this new video, I am going to solve a mathematical problem under application of matrices and determinants. So the problem is find the inverse of, so matrix is given, first row is 1, 1, minus 1, second row 2, 1, 0, third row is minus 1, 2, 3. Now we have to find the inverse of this matrix. So what is the inverse? How to find the inverse of a matrix? There is a formula to find this inverse. Now if we treat this matrix as some A, then the inverse of a matrix A is 1 by del A, that is determinant of A into adjoint A. So first you need to find the determinant of A and then you have to find the adjoint A. So how to find the adjoint A? To find adjoint A you have to find the cofactors of all these elements. How many elements are here? Totally this 3. So totally there are 9 elements. So you have to find the cofactors of all 9 elements and then you have to form a cofactor matrix. From that you have to find the adjoint A. So adjoint A is what? It is the transpose, that is change of rows into columns. So you have to change the rows and columns of cofactor matrix to get adjoint A. From that we will obtain the inverse of a matrix. So first solution. So as I told you, we have to treat this matrix as A. So we are writing given A equal to, so matrix again I am writing all these elements. So first row is 1, 1, minus 1, second row 2, 1, 0, third row minus 1, 2, 3. So like this you have to write. Then now we have to find the inverse. What is inverse here? A inverse. So formula I am writing here. So as you know, A inverse can be obtained by using this formula, that is A inverse equal to 1 by determinant of A. So I am writing that is determinant of A into adjoint A. So first what we do is we will find the determinant of A. So as it is A is in 2 vertical columns, you have to find the determinant. So this one. Now first we will find the determinant. So determinant should be, you have to enclose all these 9 elements in vertical columns. So you have to find the order of this determinant of order 3. So first I am writing all these elements 1, 1, minus 1. Now second row 2, 1, 0. Third one is minus 1, 2, 3. So first we will find the determinant. So how to this? Again plus, minus, plus. So 1. Now we have to write the minor of 1. Minor of 1 is 1. The location of 1 is, it is in first row and first column. So you have to leave those elements. So the remaining elements you have to write 1, 0, 2, 3. So 1, 0, 2, 3. Then second one minus 1. You have to write the minor of 1. So what is the minor of 1? It is in first row and second column. So leave out those elements. So remaining elements what? 2, 0, minus 1, 3. Then minus 1. Then 2, 1, minus 1, 2. Now solve this. So first what you do is, you have to multiply this main integral elements, that is 1 into 3, 1 3 jar, minus of 2 into 0. So 1 into 1 3 jar is 3, minus 2 into 0 is 0, because if you multiply any number with 0 is 0. So 2 0 is 0, minus 1, 2 3 jar is what? 6. You can multiply here, so you will get only minus 0, because 0 is there, 0 into 1 is 0. Now minus 1. Now what is 2 to jar? 2 to jar is 4. 1 into minus 1 is minus 1. Since minus 1 is there, minus, so you will get plus. So plus 1. So this will be 1 into 3 minus 0 is 3. Minus 1, 6 minus 0 is 6, minus 1 into 4 plus 1 is 5. So what is 1 3 jar? That is 3, minus 6, minus 5. Now 3 minus 6 minus, so minus 6 minus 5 means what? We have to add this minus elements first. So minus 6 minus 5 will get total is minus 11. So minus 11 plus 3. That means what? Minus 11 is the largest number, plus 3 is smallest number. So you have to subtract. So minus 11 plus 3 will get minus 8. So determinant of A is minus, which is not equal to 0, because that is the first condition. Because determinant, to find the inverse of a matrix, the determinant value should be non-zero. So we got here the value is, determinant of A is minus 8. Just put this in box. So we got the determinant of A is minus 8. Now our next task is to find adjoint A. So to find adjoint A, as I told you before, you have to find the cofactor matrix. So how to find the cofactor matrix? You have to find cofactors of all these 9 elements. So next we find cofactor matrix. So cofactor matrix. That means you have to find all the cofactors of all 9 elements. So what is cofactor of 1? So we are starting with first element, that is cofactor of 1. What is cofactor of 1? Where is the 1 location? 1 is in first row and first column. So the formula is minus 1 power I plus j. I plus j means what? I is the row position and j is the column position. So I means what? First row and j is first column. So you get 1 plus 1 into minor of aij. So minor of this element. So what is the minor of this element? This one, that is determinant of 1 0 2 3. So determinant of 1 0 2 3. So this will be minus 1 power 1 plus 1 is 2. So 1 3 jar is 3. Minus 2 into 0 0. So you get minus 1 square is 1. So 3 minus 0 is 3. So that is 3. Now you got the cofactor of 1 is 4. Next we will find the cofactor of next element. That is, it is in first row and second column. So cofactor of second element, that is also 1. So we get minus 1 power. Here what is I position? I is in first row, that is 1, plus j position is what? It is the column position. Where is the 1 located? It is in second column. So 1 plus 2 into minor of this 1. Again you have to form a determinant. So 2 0 minus 1 3. So minus 1 power 3. Now what is 2 3 jar? 6. So this one minus 0. So you get minus 1 cube is what? Because if you minus 1 whole power cube means you will get minus, because minus 1 power even number is plus, minus 1 power odd number is minus. That you have to remember. So minus 1 whole cube is minus 1 into 6. So you get minus 6. So cofactor of 1 is also over. Next we will write cofactor of minus 1. So what is cofactor of minus 1? That will be minus 1 power 1 plus 3, because minus 4 is in third column, that position. Now into minor of this minus 1. So you get determinant 2 1 minus 1 2. So you get minus 1 power 4. Now what is 2 to jar? 2 to jar is 4. So multiply this plus 1. So you get minus 1 power 4. As I told you, minus 1 power any even number is plus, positive. So plus 1. So plus 1 into 4 plus 1, that is 1 into 5. So 1, 4 plus 1 is 5. So you get 5. Now next thing, so first row is over, we'll go to the second row. So cofactor of 2. Cofactor of 2. So where is cofactor of 2 is there? It is in second row. Here I position is 2 and j position is first column, because j position is 1. So I position is 2. So you have to write minus 1 power I plus j. That means what? 1 plus 2, because okay. So I plus I is 2. J is 1, first column. So 2 plus 1. So 2 plus 1 into determinant minor of 2. What is minor of 2? Because it is in second row, first column, we have to leave those elements. So remaining elements is 1, minus 1, 2, 3. So you get minus 1 power 3. Now 1 3 jar is 3. Multiply this, because minus sign is there. 2 1 jar is 2 plus 2. So minus 1 whole cube. Again it's told minus 1 power any odd number is minus. So minus 1 into 3 plus 2 is 5. So minus 5. So cofactor of 2 is minus 5. So next. Okay. So next one is cofactor of 1. So what is cofactor of 1? So cofactor of where is 1 is there? It is in second row and second column. So I value is 2. J value is also 2. So minus 1 power 1 plus, that is 2 plus 2 into determinant. So minor of this 1. So what is this here determinant? So you have to leave those elements in second row and second column elements. Remaining elements 1, minus 1, minus 1, 3. So minus 1 power 4. Now 1 3 jar is 3. Now minus 1 into minus 1 is plus 1, because already there is another minus is there. So it will be minus. So minus 1. Now minus 1 power 4. 4 is even number, so we'll get plus 1. So 1 into 3 minus 1 is 2. So we'll get 2. Now cofactor of 1 is 2. Next, cofactor of 0. So cofactor of 0. So we'll find the cofactor of 0. So where is 0 is located? It is in second row and third column. So I position is 2, I value is 2, j value is 3. So minus 1 power 2 plus 3 into minus of 0. So you have to remove these, you have to leave out these elements in second row and third column. Remaining elements 1, 1, minus 1, 2. So you get minus 1 power 5, 1 to jar is 2, minus is there. So you get plus 1. So minus 1 power 5. What is 5? 5 is a odd number. Odd number is what? We'll get minus. So minus 1 into 2 plus 1 is 3. So you get minus 3. Now cofactor of 0 is also over. Next we'll come to the, we'll go to third row. Third row is what? Third row first element minus 1. So cofactor of minus 1. So what is the minus 1 position? It is in third row. That means I value is 3. It is in first column. J value is 1. So minus 1 power 3 plus 1. Because I value is 3, J value is 1. Into minor of minus 1. So you have to leave those elements in third row and first column. Remaining elements is what? 1, minus 1, 1, 0. So find this. Minus 1 power 3 plus 1 is 4. Now 1, 0 is 0 because if you multiply any element with 0, we will get only 0. So 0, here it is minus minus, so plus. So minus 1 power 4. 4 is what? It is an even number. So minus 1 power any even number is plus 1. So 1, 0 plus 1 is 1, so you get 1. Next, cofactor of 2. So what is cofactor of 2? So where is cofactor 2 is located? 2 again is 2 is located in third row and second column. So I value is 3 and j value is 2. So you get minus 1 power 3 plus 2 into minor of 2. So leave those elements in third row and second column. Remaining elements 1, minus 1. So 1 minus 1, 2, 0. So you get minus 1 power 5, 1, 0 is 0. So you get plus 2. So minus 1 power 5, 5 is what? It is an odd number. So minus 1 power any odd number is minus. So minus 1, 0 plus 2 is 2. So you get minus 2. So last element, ninth element is 3. So you have to find the cofactor of 3. Where is 3? It's in third column, third row and third column. So I value is 3, j value is also 3. So cofactor of 3, that is minus 1 power. So I am writing 3 plus 3 into minor of this 3. What is minor of 3? You have to leave those elements in third row and third column. So remaining elements that are determinant, that is 1, 1, 2, 1. So minus 1 power 6. Now 1 1 jar is 1, minus 2. So what is minus 1 power 6? 6 is an even number. So minus 1 power any even number is plus 1. So you get 1 minus 1. So you get minus 1. Now we have to form a, next step is you have to form a cofactor matrix. That is you have to form all the elements. So writing cofactor matrix. Cofactor matrix. That means you have to write all these elements, all these 9 elements. So I am writing here all the cofactors of all the 9 elements. Now first we'll write the cofactor of 1. What is cofactor of 1? That is first element, that is 3. So write 3 here. Next element, cofactor of 1, that you got minus 6. Then cofactor of minus 1, what is that you got? 5. Then next cofactor of 2, you got minus 5. Then cofactor of 1, you got 2. Then cofactor of 0, you got minus 3. Then last row, cofactor of minus 1, you got 1. Then cofactor of 2, you got minus 2. Then cofactor of 3, you got minus 1. So we got the cofactor matrix. So what is the next one? You need to find, see, you got the del A is got, del A we evaluated here, and next thing you need to find adjoint A. So you got the cofactor matrix. So adjoint A is what? You have to transpose this. What is the transpose matrix? You have to change row into column. So what we do is, we will change the row of the cofactor matrix into column. So that's what adjoint. So adjoint A is, So I am changing first row into first column. So you get 3 minus 6, 5. Now I change second row into second column. So minus 5, 2, minus 3. Now third row into third column. So 1, minus 2, minus 1. So this is adjoint A. Now we'll find the inverse. So A inverse equal to, so 1 by determinant of A. What is determinant of A value you got? You got minus 8. So 1 by minus 8 into, what is that? Adjoint A. Where is adjoint A? This one. Write this matrix again. 3 minus 5, 1 minus 6, 2 minus 2, 5 minus 3 minus 1. So this is how we'll find the inverse of a matrix. Now if you want to do problems of this kind, I have given a link in the description. Please click on that link so that you can do more number of problems. These videos are particularly useful to diploma and engineering students. And if you like my video, please subscribe my channel for further updates. Thank you for watching.